Hello, everyone. I'm trying to fix my settings. It's appearing dim. Can we log in? Welcome, welcome, welcome. Can we log in? I can see one person there. Kindly just log in. I have problems with my settings. I don't know why today. It's appearing dim. Welcome all. Welcome all. Kindly tell me in the chat, hi. We can high five in the chat and you tell me the group because we are combined. We have BMLS upgrading, we have oral health, we have EVH, we have BCHD, we have BPH. Hi everyone, hi. Just tell me the program. I welcome you all. Hi everyone. I'm having a challenge. I don't know whether it's my phone, which is showing my face dim, but you'll hear my voice. It's still okay. We have to move on. So things have to work. However much you have challenges. Hi. Special class. Yes, Beatrice, I can remember you. Yes, please. Just say the program and we are good to go. Welcome, everyone. Welcome. Tell others good. Yes, I've seen Winfred Zioka upgrading the MLS. Welcome. Oh, Caleb. Yes. Please welcome all. Just say program so that we can welcome everyone. BCHD, Brian. Welcome, everyone. Let's keep on logging in. I know the group is very big, so we'll give time. Yes. BCHD, welcome. Mercy, Jacinta, upgrading BMLS. Welcome. So it appears dim, but my voice will be heard, so it's okay. BPH, Betty, dominant gene. Thank you so much. Please, let's log in. Let's log in. We'll give 5 minutes for people to log in. BMLS, yes, Caroline, thank you so much. BPH, Betty, yeah, welcome all. Welcome. I appreciate every effort. BPH, Jared Kiprop, welcome in. BPH, I have almost like 100 students. So let's just try and send the link. I don't know that the link YouTube can be sent so that somebody can log in. I thought it was direct, but let's send. Ian, thank you so much. Let's log in. So all these 4 groups are doing biochemistry, the biomolecules. That's why we are together. Gemeli Grace, welcome, my dear, welcome. The name is very difficult. Pub Mobile, yes, welcome. Ogutu, yes, welcome. Please welcome all. Let's keep on welcoming everyone on board so that we have 5 minutes for welcoming before we can start. But I have to remind you people, I sent the questions. I'm trying to make it clear. I don't know why it's appearing like this, but don't worry. Don't worry. As long as the voice is there and you're back to YouTube, we don't worry. Mafusa, oh, finally, Mafusa. Yes, welcome. So as we welcome people on board and the class reps, I'll be able to recognize the presence of the class reps. Just tell me you people you are there. Pete, Akon, the class rep for oral health, I don't know her name. Elsie and Doris for BCHD. Valerie and the 2 others, please. Just tell me when you are on board. Rebecca, Achol, Alier, hey, yes, welcome. We are having challenges. It appears dim, but my voice is still there. I don't know whether I didn't charge my ring light because it's showing a bit different. And the other one, which I used the other time, also I didn't put to charge because I always use the ring light, but it's still okay. Yes, Easy Rush. Easy Rush, just say BPH, hi. Mahfuda Ahmed. Welcome all. Feel at home. We are still welcoming because people are still logging in. 5 minutes after, maybe by 9:20, we shall start, please. Vanessa Wanga, correct. I'm waiting for the other ones. Vanessa, tell me if the lady is there. I've forgotten their names. What is her name again? Let me remember. And the other guy, please welcome them on board. If you can share the link, share the link. Vanessa, I hope you shared the questions so that they can see. So we are just going to each of those questions by mentioning the number. So I'm not going to read the question because we already have the questions. For the BPH, since the group is very big, and I had to request for email address for each of the members of those groups, but now I thought if I send it to Achol earlier, yes, welcome. If I send it to Akon, everyone will be able to get, please. Yes, Akon, you are the NBG production. Yes, you are there. Another question which I have to ask Akon, did you send to them? Did they have the questions, please? If some people didn't get, just forward. Yes, Nation, welcome. Just forward, because I sent on the WhatsApp, it's easy for somebody to get. So just send them to the WhatsApp. Yes, thank you so much. Thank you. You did a very good job because the group is very big and communicating to all of them to bring them together is always very difficult. So I appreciate. Amat Garang, yes, greetings. Thank you so much. Welcome. BPH got correct. But what of the oral health? I would like to see the oral health group. Did you get the questions? We are still waiting for people to log in. We'll start by exactly 9:20 as they come in because the questions are like 3 pages. So we need to start, and I don't need to take much of the time for the students because it's already late. So if you see people coming on board, we've sacrificed, so it's okay. We appreciate all the efforts because this is the final revision to prepare us for exams. Greetings, Mora. Yes, welcome you so much. So you just tell me the group, the program, Mora, BPH, BCHD, upgrading. We'll appreciate. Elsie, you are there. BCHD are in. Thank you so much. You could have some challenges, but then I promise you that when I'm already online, we'll be able to log in. So it's okay. We are still giving 3 more minutes, and then we'll be able to start. Kindly. Peter is there. Yes, that is a class rep upgrading BMLS. Thank you so much. Wana Mafusa, again, thank you so much. Welcome. We are going to get something, and I hope it will be able to help us much by the time we are doing exams. Alia Wrestling TV, greetings, Madam Winnie. Thank you so much. Thank you. So today we are doing biomolecules, introduction to biochemistry. So maybe there are some programs, Catherine Wanyiri, welcome. There are some programs who might come on board and they see, oh, this is not what we are supposed to do. Because I have genetics, I have metabolism, but those are done already. So today is the day for the biomolecules. So if you can listen, it's still okay. Clean your damn camera. Why do you have to add the word damn camera lens? J216. No, don't tell me to clean my damn camera. You can still hear my voice. It means I struggle to make it work. So it's just okay. The students can hear me. But I don't think whether you're one of us, because for you to tell me the damn camera, that damn, doesn't seem nice. But they know my face. Only the upgrading who do not know my face. So no problem. Will still work. You can upgrade your phone or borrow one. This shitty view is destroying my eyes. No problem. You can leave. Just leave. Easy rush. You can leave. If you don't want to see, no problem. You can leave. Because we are here to learn. Dolphin Wanjiru, welcome. We are almost starting. So we can concentrate. We just concentrate on the whatever we are going to learn. There are a lot of cyberbullying, that one you are aware. So if you concentrate on the comments, you won't get anything. And you don't mind. There are people who are just idle, so it's okay. They are also allowed to write whatever they want to write. No problem. As long as we're going to get whatever we need to get. Because yesterday it wasn't like this. But I can't take time cleaning my lens because my students have to listen and have to hear something. We need to learn. So Zach Mburu, we welcome you as well, upgrading. We are almost starting. I say 20 past. Shall we start? I haven't seen the class rep for oral health 2024. 2024. Are you there? 2024? Is it 2025 January? Lady, I don't know her name. Akon, did she get the questions? Akon, just get back to me on the chat. Did she get? Akon is not there. I'm starting, please. So I'll refer to my laptop. The questions. Let me just adjust this, my position of the position. Yeah, she's called Sandra. Correct. Thank you so much. Is she here? Yeah, I'm there, ma'am. Athian, welcome. Robbie, thank you so much. We are starting. Yes, I'm here, Madam, Class Rep 2025. Thank you so much. Thank you so much. Thank you. Shall we start? So that's why we sent the questions, so that none of the students can miss. So we just follow the questions. I'll say the number. And if you have a question, if something is not clear, don't keep quiet. In the chats, I'll be able to read. I'll be able to read your questions and I'll be able to answer. Please don't keep quiet. If something is not clear, just raise it. So I'm not going to read the questions, but I'm just going to say question number 1. So if you have a paper or a pen, if you want to clarify something, you can write your own notes. But then at the end of the YouTube video, that is why the YouTube is good. It saves it automatically. By the time we were doing revisions for the cards, the Google Meet, I couldn't save it and it was lost. And I was so sorry that the students couldn't get it. But the YouTube, it is going. Diana Maingi, welcome so much. BPH 2023, we welcome you. Please stay at home and stay blessed and feel at home. Yes. So what I'm saying is, for the YouTube, by tomorrow morning, it will be saved. Will all my audio, the video, somebody saying the damn shit, clean all your damn shit lens. I think that is the wrong word to use, but it's okay. As much as you won't see my face, but you'll hear my voice, I'll be able to show clearly whatever is there. So we can start. And I separated the ASQs, the short answered questions, the way they can be brought in exam. So we have the short answered and you have the essays. The exam will be MCQs, 10 marks for whatever we've covered. Short answered questions will be 20 marks. And then the final mark will go for essays. You have 3 questions, but you have to answer only 2, which you know. Then it will total to 70. So let's start. Question number 1. So I won't be able to repeat it because it's already there, but I can mention it so that we can see what we need to answer. Draw the structure of lactose and state the monosaccharide component and the type of glycosidic bond formed. Which class is this? MBChB, AMA? No, Goni Games. This is not MBChB. If you are MBChB, it's okay. You can just log out. This is the other programs, BPH, not MBChB. Yes, I'll announce the class rep. Nancy, thank you so much. Oh, yes, Nancy, you've reminded me. You are the other one who was joining from BPH or upgrading. We welcome you. Feel at home. Draw the structure of lactose and state the monosaccharide component and the type of glycosidic bond formed. I say don't mind about my lens and my face. Let us get to the point. I don't mind about the charts. They're always there. You just know how to tackle them. Whoever feels they are in a wrong place, you just log out and then we can proceed with our thing. Draw the structure of lactose and state the monosaccharide component and the type of glycosidic bond formed. So it is 4 marks. And it clearly states the monosaccharide component are going to give us 1. Oh no, Goni Games, you missed me. Thank you so much for the missing, but I'll get you next semester. Yes, it's just like a week. Yeah? Thank you so much, my dear. We shall meet by 10th. Let me finish with my students now so that they can do exams in 1 week time. Then we'll meet for metabolism, carbohydrate next semester. Thank you so much. Say hi to the other ones. Now, I'm saying the question states, drawing the structure. Wambua, welcome, welcome. Yes, now I'll not be able to welcome, but you feel at home. Whenever you log in, we are fine. So just stay at home and let's concentrate on whatever we need to discuss. So we are mentioning 4 marks. Do you know 2 marks is going for the structure of lactose? And then 1 mark will go for the monosaccharide component. The other mark will go for the type of glycosidic bond formed. That is how I'm going to spread my marks. If you see anytime you see this question, maybe anywhere. But now, if you look at the structure of lactose very well, the first monosaccharide component should be a galactose. It has to be galactose. It has to be galactose. Because remember, if you talk about a beta D galactose, we have to remind ourselves that the cyclic form increases the solubility of those disaccharides. So the disaccharides have to be drawn. The monosaccharide components, which form the disaccharides, they have to be drawn in a cyclic form. So the first monosaccharide component is a beta D galactose. And you know, galactose, if you look at the left-hand side, carbon atom number 3 and number 4, the OH is to the left. So it means at carbon atom number 3, when you're drawing the cyclic form, you see at the back, I have a whiteboard. But writing on it, I can't project until the end. So, pole. 1 day at a time. So 1 day I'll be able to revise on the board. But for now, we are improving pole. So what I'm saying here is the first monosaccharide component has to be galactose. That is how I check the structure. If it's not galactose, then everything is wrong. So the OH at the 3rd carbon atom in that cyclic form of galactose will be inside at carbon atom number 3. But being it has to be the same position as carbon atom number 4, it means at carbon atom number 4, the OH will show up. So they'll be on the same direction, carbon atom number 3 and number 4. So it shows the first monosaccharide component when drawing lactose has to be a beta D galactose. And we are talking about beta because we said at carbon atom number 1, the OH is above. So it means at carbon atom number 1 of beta D galactose, there'll be attachment with carbon atom number 4 of beta D glucose. So most of it, the glycosidic bond will go up. It will go up and then come and bind to the 4th carbon atom. Then we are going to form a beta 1,4 glycosidic bond because the first monosaccharide component is a beta D galactose. So beta being the position is up, it's easier to extend the glycosidic bond upwards. Then it connects to the 4th carbon atom of beta D glucose. And you'll see for the beta D glucose, at that carbon atom number 1, the OH will be up. And that is what brings the reducibility characteristic of lactose. The free OH on the glucose. You've done the tests of reducing sugars. For the BMLS app, you're going to do it that week of practicals. You'll see that for lactose and some of the disaccharide like maltose, they are going to change the color of the Benedict solution from blue, because of the presence of the copper sulfate, to a copper oxide, which looks like orange if you give it some time, or brick red, whichever color you can describe, but it's going to change because of the presence of the OH at the beta D glucose. So we are talking about the monosaccharide component. You have to specify beta D galactose and beta D glucose. Somebody to write for you the first question. Epic zone. Which program? This one, they were shared. If you didn't get it, let the class rep forward to you, please. Epic, can you tell us the program so that we can connect with the class rep? They'll forward, yeah? The questions, I send them as a soft copy. So we'll be able to just follow than writing. You know, writing and then discussing can be a lot of work. You get? Yes. Please. The questions are there. I sent them. You'll be able to get them as you follow the video. So it's okay. Don't stress yourself so much. Let us just concentrate. Maybe you can have a paper and a pen to write the short notes. So we are talking about structure of lactose, monosaccharide component, the type of glycosidic bond. You've drawn the structure. The type of glycosidic bond you've mentioned, beta 1,4. Oral health. Oh, yes. The class rep, we forwarded. Sandra, Epic Zone, you can forward to him on our WhatsApp. We sent the questions. So if it's shared on WhatsApp, it will be easy. You just open as I follow from my end. So what we are saying is you have to draw the structure of lactose, but then the first monosaccharide component has to be beta D galactose. The second one is beta D glucose. And then mention that it comprises of beta D galactose and beta D glucose. Don't just say glucose and galactose. I will not give you mark. You have to specify. And then beta 1,4 glycosidic bond. Point number 2 states, or question number 2, draw a tripeptide of L, N, and W. I said, the reason why I set this question, thank you so much. Epic, thank you so much for the response or for the feedback. When I say that you draw a tripeptide, I said I'm not going to directly tell you to draw for me glycine or to draw for me serine. That one can come in essay. What I'm going to test in the short answer is a peptide. Do you know how a peptide bond looks like? Do you know the R side chain of the amino acid? Do you know which class the amino acid falls under? Can you draw the structure of the amino acid? Do you know the 1-letter codes? That's why I test it in the short answer. It captures a lot of questions at once, or a lot of areas at once. So this one shows 1-letter code of L is lysine, N is asparagine, and W is tryptophan. But I wouldn't make it that complicated, no. You know, tryptophan, if the students get it right, maybe a few of them, I'm going to make it easier for an amino acid, which almost all students can know how to draw. But you have to know the 1-letter codes. Do you know the 1-letter codes? Do you know the class where the amino acids fall? So that when you ask this question, kindly draw the amino acid separately. Draw leucine, it is under aliphatic. Draw asparagine, amide of acidic. Draw tryptophan, aromatic amino acid. You'll get the 3 marks. Already the 3 marks is there. And then come to a peptide bond. I said a peptide bond is between carboxyl terminal end of one amino acid and the amino terminal end of the other amino acid. At that point, there is a connection of the carboxyl and the amino terminal end. Water is released. And that is why I said that The similarity between glycosidic bond and a peptide bond is a release of water. At the point glycosidic bond is forming, water molecule is released. At the point a peptide bond is forming, water molecule is released as well. But the difference is glycosidic bond is for the carbohydrates and the peptide bond is for the proteins. So at this point, we are talking about draw a tripeptide. And I said the name tri, penta, tetra, di depends on the number of amino acids involved in bonding, not the number of peptide bonds, the number of amino acids involved in bonding. In this case, you're talking about 3 amino acids. So it's a tripeptide, 4 tetra, 5 penta. But now, if you can't even count the number of amino acids involved in bonding, we have a polypeptide. And that is what forms the protein. So we are saying, draw them separately. And then the last mark, the fourth mark, will go for the peptide bond. Such that if you miss the structure of tryptophan, but you got right the structure of lysine, you got right the structure of asparagine, at least you'll get 2 out of 4. Then that person who has gone straight to draw the peptide bond without each of those amino acid drawn separately. So I repeat, if you see a question talking about a peptide bond or a tripeptide, a dipeptide, a tetrapeptide, kindly draw the amino acids separately. They are going to earn you marks, each one of them, 1 mark. And then the final mark is going for the peptide bond. Did you draw it correctly? The other half mark, it's half for the peptide, the other half go for the number of water molecules which are forming. In this case, it will be plus 2 water molecules because the number of water molecules tally well with the number of peptide bonds forming. So in this case, we will have 2 of the peptide bonds forming. One will form between lysine and asparagine. The other one is between asparagine and tryptophan. So then we'll have plus 2 water molecules. Question number 3. Define monounsaturated fatty acids and polyunsaturated fatty acids and use structures to support your definition. We said fatty acids are the building blocks of the lipids. That's how simple it is. But then we classify them as saturated and unsaturated. For the saturated fatty acid, if you look at their structure, you will not see any double bond. But for the unsaturated, there will be a double bond somewhere. But still under unsaturated, we have mono and polyunsaturated. For the monounsaturated, they have at most 1 double bond. Or if the English is not Englishing, say they have 1 double bond. Don't talk about at most, at least it will confuse you. They have 1 double bond. But for the poly, if you can understand the English well, say at least 2. If the English is confusing, say 2 or more double bond. That is how they are classified. So, still, if you look at the structure of the fatty acid, we have the carboxyl end to your right. To your left, you have the methyl end. And we even mentioned, when you are drawing the fatty acid structure, you are told to draw a monounsaturated fatty acid, oleic 18:1 delta 9. Carboxyl terminal end, count from the carboxyl terminal end, 1, 2, including the carboxyl terminal end, 1, 2, 3. After the 9th, put a double bond. The carbons, the bonds around the carbon, which are those amino acids kindly? Justin, the ones which we were looking at. Justin is asking a question. Justin, L and W. Did you copy the notes? Justin, if you refer to the notes which we copied in class, or if you are the online students, but then the list of, yes, Caleb, I'm coming back to that question. Justin, If you drew the amino acids, the one letter code, L was leucine, the aliphatic ones. N was asparagine, if you look back to the notes. Amide of aspartate, and W was tryptophan. Justin, did I answer? So these are one letter codes of the amino acids. Remember we said the one letter codes are like primary key, just like your registration number. You can't share it with anyone. So the primary key, they uniquely identify an amino acid. So L, N, W, L is leucine, N is asparagine, W is tryptophan. You know this similar question? Madam, you know this. Let me answer Caleb first. What if you say at least? Caleb, if you say at least 2 in the polyunsaturated, that is correct. At least 2. It means 2 and above. But if you say at least what? At least 1. No, you can't say at least 1 in monounsaturated. You just say at most 1 because it's only 1 double bond. Simiu? Madam, in this question, then God is saying in this question, it's not correct, it's not complete. Okay, let's proceed as you ask. But then what I'm saying, define the monounsaturated, you'll get 1 mark. Define polyunsaturated, you'll get another mark. But then you'll be using structures, just draw structures. Draw structures if it is monounsaturated, and it has to be correct structure. Don't just put, because you're putting 2 of the double bonds, or you are putting 1 of the double bond. No, it has to tally. If you're talking about the monounsaturated, you have to draw well the structure of palmitoleic or oleic. If you're drawing polyunsaturated, you can draw linoleic, you can draw linolenic, you can draw arachidonic. Don't just put structures. Put structures which relates to the fatty acids. Write short notes on absolute group specificity of enzymes. Thank you, Justin. Thank you. I'll be able to answer. Good. Caleb, thank you so much. Just ask, I'll be able to see. We'll be able to answer. Because this is the final day, I'm not going to have any other revision, so we can express whatever we didn't get in class. It is good to ask questions. Don't keep quiet. Write short notes on absolute group specificity of enzymes. For the other groups, I gave it as a handout. And I told you the handout, I prepared it myself. Only 8 pages if it's too much. So this was among the specificity of enzymes. For the online BMLS, I did it in class. I think it was in form of the slides when we were covering the enzyme specificity. So we talk about enzymes being specific in nature, and we looked at the substrate specificity where they are specific to their substrate, group specificity where they were specific to the type of bond which is found in those biomolecules, because we saw the lipids, we involved the ester bond. So we are talking about the esterase. So the ester bond is involved there. And then we had the peptide bond in the proteins. That is group specificity. And then we have an example of glycosidase where we had the maltase, breaking down the maltose into 2 glucose units. So if I write 18:1 delta 9 and name oleic and note structure, is there a mark? Based on how the question says, let me ask you, why would you go against whatever the question is asking? Wana mafusa. If you answer it like this, it means, let me restructure the question. In this question, you asked last time in the card, I define them. Then I give you structure after I define them, and you mark definition, but structure doesn't mark. Huh? Then, let me answer Mafusa first, then I'll answer you. So, Mafusa, you know, we can't start by writing delta without defining. The way I can restructure this question is, I'll tell you, draw 18:1 delta 9 and give its common name. Mafusa? Because if you show me this one, I'll not give you any mark. That is not what I asked. Because I told you to define. Yes, it falls under monounsaturated. Did you define monounsaturated at that point? If you define it, I'll give you 1 mark. But this is not the structure. That is the position of the double bond and the common name. In here, I didn't say any common name or the position of the double bond. So I'll tell you, draw 18:1 delta 9 and give the common name. You get? Then we'll be able to answer this. But if you answer me with this one, in relation to the question which I have here, I'm not going to give you any mark because I want you to define for me monounsaturated, polyunsaturated. Give me the structure. This is not the structure. This is the position of the double bond and the common name. Mafusa, I try to answer, but it can be restructured. This can be restructured by showing you need to draw for me this structure of a fatty acid, be it saturated or unsaturated, but then position of the double bond, which has to be precise. Let me do the, Kwotolel is saying we can revise fast and you ask questions later on. I think the idea of Quartel is good because, do you agree, or I should let people say something? Quartel, Mabor is giving an opinion. Yeah? Then, before I can answer, I need to understand what you're saying. You asked last time in the cart. When? We haven't done a cart of fatty acids. I said, that is what I'm going to give for 10 marks. A question of fatty acid and a question of a peptide. Good. Cosmos agrees that we finish the revision, but then as we finish, please just write down the questions that you like to ask and then you'll go to the chat. Good. Everyone agrees with Mabor. So we'll proceed with the revision by mentioning the number of the question we discuss, but then write down whoever has questions. When we are done, good. Even Peter agrees. So when we are done, then you can ask the question. I'll be able to answer them, even if I answer until 1. I told you today is your day. So let us proceed with the revision. And then at the end of it, then we can. Some of us joined a few minutes ago. Kindly repeat the previous questions. Oh, Dylan. Dylan, did I go far? I'll repeat. It will be unfair. But now, Dylan, you have to promise me that whoever comes again, we won't repeat because then we won't move. Don't you think I should repeat for Dylan's case? I want people to agree, and now everyone agrees whatever Mabor said. Can you suggest what I should tell Dylan? Because we are at number 4. We haven't gone that far. Dylan, where did you get us? Did you get us at fatty acids, Dylan? I need a feedback from you. Or I can proceed and then I'll go back. Dylan, I'll go back. Those who came late, revisit the channel tomorrow by their own. He can follow after the live. Yes. Dylan, I hope they're not mean with their points. He will watch after. Because, Dylan, this thing, thank you. This thing is going to be saved. The YouTube will save it automatically. So you'll be able to get, at 18:delta 9. They are not mean with their comments, but then it's going to be saved, huh? So I hope you take it positively. We are at number 5, but I hope you have the questions. Good. They are saying we can rewatch because it's going to be saved. By tomorrow, you'll be able to see. So let us just proceed. The ones who have questions, please write it down. I'll be able to answer all of them before we can finish, because today is our day. So everyone has agreed. Let us proceed. And then after that, we'll work on the questions. We are at number 5. Did I finish up? No, I didn't finish absolute group specificity. Sorry. We are talking about specificity of enzymes. And I'm saying the group specificity deals with the type of bond which is found in these biomolecules. If you talk about glycosidic bond, if you talk about ester bond in the lipids, if you talk about a peptide bond, so you will find that the proteases will just work on the peptide bond because they're digesting proteins. But if you look at the absolute group specificity, it's a specificity which is of high order. High order meaning that as much as chymotrypsin, which is a protein digesting enzyme, works on a peptide bond because of the name group, but being absolute, it's another level because it works on a peptide bond, but checks if the peptide bond at the carboxyl terminal end, we have aromatic amino acids. The aromatic amino acids like tyrosine, like phenylalanine, like tryptophan, chymotrypsin, absolute group specificity. It works on peptide bond, yes, because it's a protease, but checks at the carboxyl terminal end, do we have any of aromatic amino acid? It will cut. Trypsin, another example, a protein digesting enzyme, checks in the chain. Carboxyl terminal end, do we have a basic amino acid? It will cut. Does it have histidine? Does it have arginine? Does it have lysine? It will cut. So for absolute group specificity, it is a high order of group specificity. Question number 5. Define epimers. Define epimers. I've not gone too much far with the BPH marking, but for the BCHD, we'll correct the mistakes which we made. People were skipping the epimers because I combined functional isomers and epimers. And I said, epimers, monosaccharides, they are of the same molecular formula, same functional group. Remember epimers, even ketoses, they're epimers. Aldoses, they're epimers. But there is a change at a specific carbon atom, which is not the carbon carrying the functional group. We talk about the carbonyl carbon. There is a change at a specific carbon atom, but not the carbonyl carbon. Those are epimers. So after defining the epimers, for you to get the 4 marks, definition will give you 1 mark. But in this case, I want you to put the 3 structures, glucose being the reference point. We have D-glucose, we have D-mannose, and we have D-galactose. Imagine it was very fair. Somebody just draws a D-glucose and the other one is even L-mannose. I give you mark for this D-glucose because if you draw for me D-glucose and then you're going to draw L-mannose, everything should be wrong in those structures. Because if you are comparing the epimers, or if you're saying mannose is an epimer of glucose, and it has to be that way, not glucose being an epimer of mannose. Mannose is an epimer of glucose at carbon atom number 2. It has to be D-mannose and D-glucose. If it is L, it is L. If it is D, it is D, even structurally. Then D-glucose and D-galactose. D-galactose is an epimer of D-glucose at carbon atom number 4. Or L-galactose is an epimer of L-glucose at carbon atom number 4. Imagine, that is how the marks are coming. Very easy. Define 1 mark. Draw the structure of D-glucose if you are dealing with D-glucose. D-galactose, D-mannose, and then state at carbon atom number 2 and at carbon atom number 4. for galactose and for mannose. Simple. You get the marks. But then functional isomers, do you know some people are still drawing stereoisomers? They are of the same molecular formula, but most of the people got it. The difference in structure comes about because of the different functional group. One has to be a ketose, the other one has to be an aldose for functional isomers. But then stereoisomers, they're of the same molecular formula. They're still hexoses, C6H12O6, but the other one is a mirror image of the other. You talk about D-glucose, then we could draw L in class, D-mannose, and then we could draw L-mannose. So stereoisomers are the mirror images of one another. Functional isomers, the structure, the difference in structure is brought about by the difference in the functional group. One has to be a ketose, the other one has to be an aldose. And then epimers, they're of the same functional group, but there is a difference, a change at a specific carbon atom, which is not the carbon carrying the functional group. Simple. I tell you, if you calculate how to get a 50, very easy. You look at section A, MCQs. Getting a 6 is easy. I told you I set what I teach. I don't set things from the blues. I don't frustrate any student's life. If you read very well and you attend and we revise, my friend, we are going to pass. Then you go to short answered questions. Because even the external examiner wants to see you covering all the areas which you taught. And at least we got something. You go and get a 10 out of 20. Already that's a 16. Imagine essays is the best place to get a lot of marks. Because I'll have to give a question on the carbohydrates. I have to give a question on the fatty acids. I have to give a question on the amino acids or the proteins. But the secret is, in my exam, I will exercise on the structures. We have to know how to draw the structures. So it shall be well. So I say question number 6, with reference to relevant structures, distinguish between Keto-triose and Keto-hexose. We said naming of the monosaccharides is based on 2 criteria: the functional group and the number of carbon atoms in the main skeleton. So if you talk about a keto-triose, the second carbon for ketosis will always have a keto group. But then it has 3 carbon atoms. So the keto stands for the functional group. The triose stands for the number of carbon atoms. So you can draw the structure of dihydroxyacetone. And drawing these structures are very easy. As long as you know for the ketosis, the first carbon has to be CH2OH, the second carbon has to C double bond O, then just play around with the carbon atom number 3 to number 6 if it's hexose. But in this case, the last carbon will be CH2OH. So number 1 CH2OH, number 3 CH2OH, the second carbon has the keto group. That is keto-triose. And then the keto-hexose, where fructose falls. Carbon atom number 1, still CH2OH. Carbon atom number 2, C double bond O. It means you are drawing D-fructose. I said to the left-hand side, carbon atom number 3, put the OH. Put the hydrogen the other side. Carbon atom number 4 and number 5, the OH will be to the right. You balance with the hydrogen this side. It means the carbon atom number 6 is CH2OH. Just what I want you to see here, can we draw the structures of those monosaccharides? Do we know the linear form? Can we know the functional group, the number of carbon atoms? We are trying to test a lot of things at a go. But you make it broad so that the student can have a broader picture on how the question should be answered. Then question number B, still on number 6, cysteine and serine. Here I was making it very simple. In fact, this was a time when biochemistry was introduced to the students. So you make it simple. By now, I can't tell you to draw for me cysteine and serine. Only if it comes to essay. I can talk about monoamino, monocarboxy, any 10. That is where you can draw them. So in this case, I tell you to draw for me cysteine. You know, cysteine is sulfur containing. I told you when you're drawing the amino acid structure, the amino terminal end, the carboxyl terminal end, the alpha carbon and the hydrogen is same for all the 20 amino acids. What differs is only the R side chain. So if you talk about the R side chain, for the cysteine, we have CH2SH, the presence of sulfur. And I said, you have to bear in mind that sulfur is atomic number 16. So the configuration has to go to 286. So what you need is 2 bonds around the sulfur. They have to balance. But then serine was falling under the alcohol containing, or the ones which were having OH on the R side chain. So you'll have the carboxyl, the amino, the alpha carbon, the hydrogen up there. But then on the R side chain, we will have CH2OH. The presence of the OH on the serine will make it to stand tall, and it falls under the alcohol containing. So in this case, I'm just trying to test, do the students know which class the amino acids falls under? And based on the R side chain, are they be able to draw an amino acid, carboxyl, amino terminal end, alpha carbon, hydrogen, and the R side chain to be drawn correctly? Differentiate between unsaturated and saturated fatty acids. Question number 7. Unsaturated, simple. They have double bond. Don't even go further and explaining to me that we have mono and poly. No. What the question asked, we only have 2 hours for the exam. So you say unsaturated fatty acid, double bond present. Saturated fatty acid, double bond absent. Simple. Give structures of the difference the way you've just defined them. Unsaturated, you can draw any, be it mono or poly, palmitoleic, oleic, arachidonic, linoleic, linolenic. But then saturated is always very simple. There is no double bond. So you can draw lauric, you can draw myristate, you can draw palmitate, you can draw arachidic, you can draw several. Stearic. So this is the simplest because it doesn't involve the mono and poly. For saturated, drawing is easy. So you can just take C16. You just draw 16 carbon atoms as long as you put the COH to your right. Left, put your methyl. It's okay. Number 8, show the similarity and difference between alpha L glucose and beta L galactose. If I say show similarity and difference, structural, don't write stories. I don't need column for L galactose and L glucose. No. Draw for me structures. You know, the similarity which I'll spot there, they are both aldoses. So they are going to form the pyranose ring. The difference which I'm going to note there is simple. One, I'm talking about beta. The other one is alpha. I want the student to kindly tell me the difference between alpha and beta. So just draw the structures. And also, one mistake which the students were making, I tell you to draw for me alpha L mannose. And you look at the student drawing well, the linear form. Because remember, the linear is the one which now we are projecting into a cyclic form. They draw the L mannose very well. But now, what was touching me was the structure which they were drawing. And that's why I gave half-half. As long as you put the OH above for beta and OH below at carbon atom number 1 for alpha, imagine I was giving half. And in the exam, I'm not going to give a half. If the whole structure is wrong, it's wrong. So I was giving half because you find that the student got the concept right. it is beta, it is alpha. But now, at the point of carbon atom number 2 and number 3, to bring the OH outside for L-mannose, you know, if you put it inside, most students are putting it inside, it means you are drawing for me D-mannose, alpha D-mannose. Remember L, the OH, has to come to the right-hand side. So it has to come outside the ring. That is where the mistake was. So as much as I'm seeing, you can't get all the 2 marks, I was giving half because you have an idea. It should be up for beta, below for alpha. I can't just leave you without a mark. But in the main exam, that's why I'm revising. Kindly, let us get it right. You can draw the linear form, and then for the aldoses, I said, go straight. Do the pyranose ring. For the ketoses, or for the fructose, sorry, and the pentoses, go straight and do the furan ring. And basically, I'll just ask for fructose, the 5-membered ring. And when you are placing fructose, don't interfere with carbon atom number 6. The CH2OH should just stand there. If you're told to draw a beta L fructose, for example, the beta and the alpha, whether L or D, just relies on the changes from carbon atom number 1 to carbon atom number 4. 5 already form the furanose ring. 6 is seated there quietly. You know, sometimes when I talk about the L, they even change the position of the CH2 at carbon atom number 6. Only at 1 is where the position changes. If it is beta for fructose, the OH is above, CH2 OH is below. Because the first carbon has to be CH2OH now. The carbon atom number 2 already forms the hemiketal. So if it is alpha, the OH will come down, CH2OH will be up. That is where most of the confusion come in. So you know very well, if it's L, our OH will come outside the ring at carbon atom number 3. At carbon atom number 4, it will go inside the ring. Then number 5 already, there is a hemiketal. Leave the CH2OH number 6 quietly seated there. Don't interfere with it by bringing it down. And then I don't know where the H is going to. No. So we are just working on how to differentiate the 2 structures, L-glucose, beta-L-galactose. Draw in a linear form, but start by looking at, is it an aldose or a ketose? Do the pyranose. And remember the hemiacetal, it has to be, the covalent bond has to show there. It is not just something which is sealed. There has to be a circle there which connects to show that it's hemiacetal for the aldoses and the hemiketal for the fructose and the pentoses. So this is how the structure should be. No? Now the OH at carbon atom number 3 should not be inside, but should come outside. The OH at carbon atom number 2 should go inside. You get. So it means at carbon atom number 4, it should be down. Because if you put it up, it shows you're drawing galactose. So the other question for L-galactose was, where people are confusing, you find somebody putting the OH at carbon atom number 3, 4, and carbon atom number 2, all one direction. You know the L-galactose, in the cyclic form, it should not be inside. At carbon atom number 3, it should be outside. And then at carbon atom number 4, should also be the same direction as the carbon atom number 3. So we should not confuse the 2. If you know how to draw the linear form, draw it correctly and see. The position where it was to the right, it always come outside the ring. To the left, always come inside the ring. Just as you can twist your chain in clockwise direction, then you'll get it right. But most students were getting it right, of course. I'm just trying to highlight a bit of the small errors which can cost us our marks, which we saw in the cut, so that we don't repeat the same. Clearly show the structural difference between palmitoleic, linoleic, oleic, and linolenic fatty acids. I just need structures. So you just write for me up there. This is palmitoleic. Palmitoleic is 16:1 delta 9, the monounsaturated. Draw it. Carboxyl terminal N. I told you 3 formulas of drawing them. But the best formula is the one which we did in class. You just do C, COH, yes. And then there is one, which is in the channel, which I didn't do in class. I didn't put in the handout. The ones with the lines, which is easier for you. And then the last bit, which is the handout. For the BMLS upgrading, it's on the table, the one on the table. With the summarized CH2 bracket 7, COH. That one needs when you know all this, so you can have to draw the other one in that format. But it's still okay. Any of them, don't draw all of them. Just draw one of the formulas, the pattern which you understand better. But I think the one for drawing all the carbons with the hydrogen connected is very easy. Everyone can understand that. So what I was saying was palmitoleic. You just put up there palmitoleic. It's always C16:1 delta 9. And then you have linoleic. 18:2 delta 9 stroke 12. And then we have linolenic, just by adding N, 18:3 delta 9, 12, and 15. So I said I don't use omega-3, omega-6, and omega-9. That is just for you to know. The products which are sold on the shelf in the supermarket, you'll always see a component of those oils. Somebody talk about omega-3, omega-6, omega-9. So you should just know them. But then the common names which I always use are the oleic, linoleic, linolenic. Yes? So whatever we are saying, epic zone, you can write it. You can write it somewhere. We agreed we finish. After finishing, then you can ask a question. So just write them down. I'll be able to answer. Yes? So we can proceed. Oleic, I didn't mention oleic. Oleic is 18:1 delta 9. Question number 10. We are not badly off. Aspartate and lysine are 2 different amino acids classified into different classes based on their R group. Aspartate and lysine. So you are told, mention the groups and structurally differentiate the 2. You know, aspartate falls under acidic. Lysine fall under basic. So if you draw the structure of aspartate, we had the R side chain having the CH2COOH. The presence of the COOH brings the acidic property of aspartate. But then, if you talk about lysine, it is basic. But lysine is the simplest. You have 4 of the CH2s, then the NH2. The NH2 or the amine group will give it a characteristic of a base. So it will act more like a base. So we talk about the class of aspartate being acidic, the class of lysine being basic, but then when you draw the structures, it tells much about the side chain where the amino acid fall. Write short notes on any 4 classes of enzymes. The handout which I brought on Friday in class, it has the enzymes. But that is what I skipped. You know, at the point when I was already leaving, I thought I didn't mention it, but it was very important to mention it. The enzymes are classified into 6 classes based on the reaction which they catalyze. So you have the oxidoreductases, you have the hydrolases, you have the transferases, you have the isomerases, you have the ligases. Are they already 5? Yeah. But then they are classified based on the reaction or the mechanism of reaction which takes place. So you can mention any of those classes of enzymes and mention the type of reaction because it has been mentioned there. It's just one line. That's why they're saying mentioning the enzyme, you'll get half a mark. And just by defining the role of that class of enzyme, you get another mark so that it adds to 4. So any 4. Writing short notes doesn't mean you write a lot. Just mention and you write the roles of those enzymes in those class. Write short notes on unsaturated fatty acids and give any 2 structures. So for some which we already covered, we'll be able to move a bit faster so that you don't take much of the time. So we said the unsaturated fatty acid, they have double bond. Give any 2 structure. You can draw the structure of any mono unsaturated and any poly unsaturated, of which we've seen in the previous questions. Define pyranoses and furanoses and one structural example to support your definition. You know, the definition of furanoses and pyranoses is very simple. The 5-membered ring, the monosaccharides, which form a 5-membered ring, are the furanoses. The ones which form a 6-membered ring are the pyranoses. And then, you know, even if you don't draw it correctly, but you can also just give me, you see that 6 corners with the hemiacetal for the pyranoses, you'll get your mark. If you decide you can draw for me a glucose which is complete, is also fine. But even that person who did not complete it with the H everywhere, it's still right as long as the 6-membered ring is showing. Even after defining, it's okay. So you can draw the structure of glucose, galactose, mannose for the pyranoses, or you can just draw the 6-membered ring. You'll still get your mark. For the furanoses, you can draw the fructose or the 5-membered ring. You will get your mark. You know, some students were defining it as a 5-carbon ring. No, not ring. There was no ring. A 5-carbon. Because if it's ring, it seems to be correct. Because it's forming something which is ring-like structure. 5-carbon ring. Without the ring, they talk about 5-carbon. You know, 5-carbon is pentose. 6-carbon. 6-carbon is hexose. But the ring, the part of the ring, adds more value. So, differentiate between fibrous and globular proteins and give 2 examples in each case. So this was classification of proteins based on shape. If you look at the globular proteins from the name, where the globulins were, the fibrous proteins, these are the ones which are not soluble. They are insoluble ones. The collagens, which has to be converted to a soluble, water-soluble gelatin. So you have those examples. You just define them and then you give any of those examples. Using one structural example, define and differentiate between mono and poly. I think that is too much. I've done it up there. So we'll be able to refer to the mono, 1 double bond, poly, 2 or more double bonds. Mono, draw palmitoleic or oleic. Poly, you can draw linolenic, linoleic, or arachidonic. Draw a tetrapeptide of phase. I said we can exercise these peptides using our names. We can use our names in describing the peptides. These people who are telling me about the lens, let me see if it works. Is it better? Somebody talking about the lens. Okay. They want to see my face. You want to see my face, but my voice is there. Is it better? It's not better. But it's okay. We'll proceed. Oh, no. I need to adjust the camera. Yes, it's okay. So I'm saying that based on the amino acids, one letter code, we'll be able to draw the peptides. So if you talk about face, it means F was phenylalanine, A was alanine, C cysteine, and E glutamate. I mention and I repeat. Good. Oh, good too. Thank you. If you can cope with me, because the people who are saying the lens, I don't know whether they are in board, because I also think, oh, thank you so much. Thank you so much for adjusting. Thank you so much for the patience. Now we are saying that if you look at FACE, I said, kindly, if you see that question, draw the amino acids separately. Draw each of the amino acids separately. It's going to give you the 4 marks. In this case, it's going to give us the 4 marks. 1 mark for phenylalanine structure, 1 mark for alanine, 1 mark for cysteine, 1 mark for glutamate. Then come, because I'm testing, do you know the 1 letter code? Do you know the R side chain of this amino acid? Can you tell what a peptide bond looks like? Carboxyl, amino, with a release of water. Kindly draw them separately. It will save you a big deal, because you might miss the structure of phenylalanine, but you'll get the marks for the structure of the other 3. So instead of you having that 1 peptide bond where you missed a point, you'll get a 0 out of 5. In this case, you'll be able to get a 3 out of 5. At least you'll get a mark. So put them. And don't try to rearrange them. The way it says, a tetrapeptide face. That is the sequence. That's how it should be. Don't bring A because you say, oh, I know alanine, to draw alanine more than cysteine. Glutamate more than phenylalanine. No. It has to be FACE. But then the peptide bond. In between where there is a peptide bond, a water is going to be released. So after drawing the peptide bond, put plus 3H2O. So we talk about a tetrapeptide because 4 of the amino acids are involved. Question number 17. Draw structure of any three monoamino monocarboxylic amino acids. This one will cover as a general question, which can come even in essay. So I'll start by this question the way it asks. So draw structure of any 3 monoamino monocarboxylic. If you look at the structure, the general structure of the amino acid, you look at the carboxyl terminal end and amino terminal end. How many carboxyl group and how many amino group do we have? In this case, even if you look at the R side chain, you look at the carboxyl, the amino terminal end, everywhere in the structure of amino acid, we only have 1 amino group, 1 carboxyl group. It means all the aliphatics fall under monoamino monocarboxylic. All the sulfur containing falls under the monoamino monocarboxylic. All the alcohol containing fall under the monoamino monocarboxylic. And the list continues, even for the aromatic, monoamino monocarboxylic. But sometimes we talk about diamino dicarboxylic. 2 of amino groups, look at the structure, the whole structure of amino acid. 2 of the amino groups, 2 of the carboxyl groups. And that's why we said for diamino dicarboxylic, amides of acidic fall under that class. Asparagine and glutamine, they will be falling under the diamino dicarboxylic. Then you have dicarboxylic monoamino. all the acidic aspartate and glutamate will fall under that class. Then you have one unique one, diamino monocarboxylic. Only lysine will fall under it. So we are saying we looked at the classification of amino acid. We started with the R side chain, we drew it, and we saw the 20 amino acid. They are different based on the R side chain. Then we looked at the nutritional classification of amino acid. We looked at the essential amino acids and the non-essential amino acids. The ones which can be provided in the diet and the ones which are synthesized by the body. Question can come on that. Then we looked at based on the number of amino and carboxyl groups present. So it can come on its own way. Even based on charge, we looked at the neutral, the basic, and the acidic. So in the essay part, section C, if we have to cover amino acids, we need to understand the other classification of amino acids. It could be broad nutritional classification, or somebody can say essential amino acid. You can draw any 8 structures, 1 letter code and 3 letter codes, but you have to define based on. Caro, do you have the questions? Chapter Nui, which program? Please, we need to assist. Tell me which program, because I sent a soft copy. If you are writing, then you are going to write until the day ends, the night ends. And that is what I was trying to avoid. Do you have? Which program? Because the class rep can send it to you on WhatsApp. I'm going through the way I sent BMLS. Oh no. Peter, can you share with Caro? Are you among the BMLS upgrading with Peter? Peter can share it on WhatsApp so that you can see, because I'm just going by the questions, the way we shared. So let Peter share it as we proceed, please. You can't write all this. It will be hectic even from your end. So I had a soft copy of the questions. So I just mentioned question number this, question number this. Caro, is that one fine? Please, Peter will share. Good. We have the questions in our BMLS class. Peter, P. Ogutu, BMLS class. Oh yes, Ogutu is saying they have. I've shared in the group. Kindly. Chapter Nui. I don't understand your point. You want me to repeat? Repeat the answer. Okay. Yeah, that one I can understand, because the whole question is too much. So I'm saying, the question says, draw all. Huh? Was I already there? No, question number 18, I haven't read there. Was I at 17? I was at 17. And then I see the 18. I've also answered 18. But let me repeat. Question number 17, I said you have to draw structure of any 3 monoamino monocarboxylic. Caro, I said based on the number of carboxyl and amino groups, we'll be able to classify the amino acids as diamino, dicarboxylic, monoamino, monocarboxylic, dicarboxylic, monoamino, and diamino, monocarboxylic. So for question number 17, drawing any 3 monoamino, monocarboxylic is very simple. The ones with 1 amino group, 1 carboxyl group, you can draw glycine, you can draw alanine, you can draw valine, you can draw isoleucine, you can draw leucine, even proline can fit in there. You can draw serine, threonine, cysteine, methane, there are several. As long as if you look at the whole structure, plus the R side chain, it's only 1 carboxyl group and 1 amino group. And that one brings us to question number 18. Draw all the diamino. There is a reason why I say all. For diamino dicarboxylic and dicarboxylic monoamino, because there are only 2, diamino dicarboxylic, we have the asparagine and glutamine only. 2 amino groups, 2 carboxyl groups. There is a carboxyl group on the R side chain There is carboxyl group at the carboxyl terminal end. There is amino group at the R side chain. There is amino group at the amino terminal end. So they are dicarboxylic diamino. That is asparagine and glutamine. Then the other one is monoamino dicarboxylic. Those are acidic amino acids. We are answering question number 18. So each of the structures, you draw for me asparagine, you get 1 mark. You draw for me glutamine, you get another mark. You draw for me aspartate, you get a mark. You draw for me glutamate, you get a mark. So it's both the acidic and the amides. If you draw them, you get the 4 marks. Caro, did I try? Number 19 talks about epimers. We already answered epimers somewhere up there, but it says draw 2 structures. 2 structures. You know, when I say 2 structures, you have to draw for me either glucose and mannose or glucose and galactose. I've said 2 structures. Draw 2 structures in each case to define and differentiate. I think the story was differentiate between epimers and functional isomers, because if it's written the way it is written like that, the 4 marks will not enter. Draw 2 structures in each case to define and differentiate between epimers and functional isomers. So if you draw for me mannose and glucose, D to be precise or L to be precise, and then you write for me epimers up there, I'll just add to myself and I know nitajijazia. In Kiswahili, we say nitajijazia. I'll add it to myself and I'll know this is what you meant. And then there is one for functional isomers. That is how the question was supposed to be. So functional isomers, we don't define anything. You just draw fructose and glucose. Draw 2 structures in each case to differentiate between epimers and functional isomers. Question number 20. We've done tripeptide. Yani, if somebody gets it wrong in CAT, I've been singing the peptide, and they've been coming. Now this is a tripeptide age. I say, draw alanine there, 1 mark. Draw glycine there, another mark. Draw glutamate there, another mark. Come with the peptide bond, a 1/2 mark. 2 water molecules plus 2 water molecules, 4 marks. Peptide. I've been talking about peptide. Very good. You see how we are balancing? Because most of them are going to come from the carbohydrates, from the amino acids, from the fatty acids. And we have to draw structures. Almost 90% we have to draw structures, which is fine. You're good to go. Define functional isomers and give structures of 2 monosaccharides to support your definition. See, functional isomers, we said, they're of the same molecular formula. But structurally, they're different. But the difference in structure is brought about because of the difference in the functional group. So you'll give me the structure of D-glucose and D-fructose. Or even D-galactose and D-fructose. They're ketoses. The other ones are aldoses. So we have to, with reference to relevant structures, distinguish the following. Beta-L mannose. Yes, this is what I had said in the CAT. Beta-L mannose and beta-L galactose. In fact, there was an alpha. That was alpha-L mannose and beta-L galactose, to be precise. So what I'm seeing here is you just have to draw the mannose and galactose. They're both aldoses. So it will be 6-membered ring. But then the beta, both of them at carbon atom number 1 will have the OH above. And remember, I talk about draw for me mannose. Somebody is still drawing something which looks like a disaccharide. 2 monosaccharide units. We need to get the questions right, kindly. When I see like such, I feel like crying. You know, when one sheep is lost, we better get the one sheep and leave the 99 to wait for us. I talk about mannose. Somebody still draws like a disaccharide. I don't know whether it's confusing between mannose and maltose, but when we talk about mannose, they are monosaccharides. They're simple sugars. You can't break them further. And then we have beta L galactose. So for the L's, remember, when you are drawing mannose, to the left-hand side, we had at carbon atom number 2 and carbon atom number 3, the OH was to the left. Meaning now, the OHs will come outside the ring because it is L mannose. Same with galactose, the L form, the OH at carbon atom number 3 will come outside. It means at carbon atom number 4, it will be in the same direction as the one at carbon atom number 3. So that is a mistake the students were making. Bringing the OHs to move this other side, they leave them as D, but they forget to move. And then the ones which were on the right will move inside. It means at carbon atom number 2, for L-galactose, beta L-galactose, it will go inside. That's how simple it is. You just play around with carbon atom number 2, 3, and 4. Because already 5 is involved in bonding, 6 already sitting there, 1 is already the one determining whether it is a beta or an alpha. Just play around. 3, 4, and 5, and it shall be well. We are at page 2. We are at page 2. Question number, how did I write the question? Let me see. Did I number it 20? Yes, 23. Oh, there is a question here down there, number 22. Relevant structures, distinguish the following: linolenic and linoleic. You know, linolenic has 3 double bonds. It is the 18,3 delta 9, 12, and 15. Linoleic has 2 double bonds. They are both polyunsaturated, but linoleic is 18:2 delta 9 stroke 12. You'll draw them very well. Carboxyl terminal end. Amino. And I said, if you can't balance the C double bond O minus, put COOH. Don't struggle so much. Then balance the bonds around the carbon. Things will be fine. But don't bring carboxyl this side and bring for me methyl the other side. No. Don't try to interchange the positions. I'll give you a very big wrong. Carboxyl terminal end. Most of the structures from most of the biochemists, the carboxyl terminal end is to the right. Methyl end is to the left. Write short notes on substrate specificity of enzymes. Very simple. Well, we talked about how galactokinase is specific for galactose. Fructokinase is specific to fructose. Glucokinase specific to glucose. That is the substrate specificity when we are looking at the specificity of enzyme, the first specificity. You know, I can't read WhatsApp. Somebody saying, Madam, it is me in WhatsApp, though it shows me the notification. I hope it's not something serious, which they need to attend the online class, the online revision. So the question number 24, my upgrading, I'm not teaching the buffer and water, but this one fall under the characteristics or properties of water. Those ones we can read on our own for my other students who are not upgrading. And remember, I didn't even include much of deriving the Henderson-Hasselbalch equation and the pH of water. It doesn't mean that they don't come. They will come. They will come. My friend, they will come. Either derive the Henderson-Hasselbalch equation or derive the pH of water as 7. It will come. It has to come for the other students. Not BMLS. BMLS, we are not going to do water and buffers anywhere in the exam. But my other students, it's going to come. And that is where people were making some mistakes as well. when you are deriving, the pH of water is 7. At that point where you are talking about 1 mole equivalent to 18 grams, and then you talk about the 1,000 grams per liter. Some people just cook things in between here and they write 55.56. Then it reaches a point of the decimal. You put 0.556 times 10 to minus 2. That is wrong. It is a positive because it should take us 2 steps forward to our initial value of 55.56. If it's a negative, then it is wrong. It's not even going to give us 1.02 to power minus 14. So let us be sure with the steps which we're writing. And most students were writing the equation for water as a buffer. No, that one I don't need. I need the equation where water dissociates to hydrogen ion and hydroxyl ion. And at that point, don't write concentration. It is just the dissociation of water and KQ up there. And even at the point you'll be deriving the Henderson-Hasselbalch equation, kindly put for me the concentration in a good way. If you put the normal bracket, that is not concentration. The square bracket is the concentration. So let us be precise with whatever we are describing. If it is pH, do the necessary. The KQ has to be there. If it is Henderson-Hasselbalch equation, it is Ka. And clearly define negative of log hydrogen ion concentration is the pH. So for any of those properties of water, we can discuss, we can revise on our own, and you'll be able to understand. That's why I didn't put much of water and buffers here. So you'll write short notes on high heat capacity as a property of water. You can read any of those properties of water because it can be brought for the other groups, not the BMLS upgrading. Let us move to essay. I know people are already exhausted. Oh no, it's already 10:40. No, but it will pay. It will pay. If you're still attentive, it will pay, my friends. It will pay. Don't worry. Be patient. Essay, it's continuous. The numbering is continuous. Number 25. Using 4 structural examples in each case, my friend. I'm telling you, my exam is very easy. If we can't pass this one, then I don't know which one we can pass. Using 4 structural examples in each case, discuss 2 criteria which naming of monosaccharide is based on. 20 marks. Imagine. I'm just giving it for free, like that. You say, point number 1, based on the functional group. You'll get a point. You know, they have to add to 20. On the functional group, that is the mistake the students were making. Even at the point I was marking the cut. I just said, that one I specified based on the functional group. So you have to tell me the first functional group being aldose or an aldehyde group. It has an aldehyde group, aldoses. They have an aldehyde group at carbon atom number 1. We'll give you full mark. But if you just say aldose, ketose, half. Aldoses, functional group at carbon atom number 1. Full stop. Ketosis, functional group at carbon atom number 2. Full mark. Then you will give examples. Here they are saying 4. It means each of the examples will give you half, 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 half. So for the functional group in this case, you know, you'll get to know how to draw glucose, galactose, and mannose. You shall have already gotten 3 marks. The 4th one, under functional group, you will add is glyceraldehyde. Then you go to ketose. You know, it's 20 marks. Not a joke. Give me fructose. Give me erythrulose. You can give me ribulose. You can give me dihydroxyacetone. Full stop. And even for the ribulose, I was not even looking at the position of the OH. As long as I can see the carbon atom number 1 is CH2OH, the second is C double bond O. Then the other ones put the 5 marks, the other 3 carbons, sorry. Then I'll give you a mark. And then now This other criteria is based on the number of carbon atoms. You get another mark. Imagine just by mentioning 3 carbons, triose, 1 mark. 4 carbons, tetrose, another mark. 5 carbons, pentose, mark. 6 carbons, hexose, marks. Then you can draw the structures of whatever you drew up there. As long as now you can draw one of the hexoses. It can be fructose, it can be glucose, it can be galactose, it can be mannose. 5 carbon. It can be ribulose, which you drew up there. Nobody is going to penalize you that you've repeated yourself. Here we are talking about the number of carbon atoms. This is 6 carbon, this is 5 carbon, this is 3 carbon, this is 4 carbon. Imagine, you will get all your marks. I'll not even go with any. I tell you, sometimes students get a 67 out of 70 until you ask yourself, can I reduce it to 65? Because even people will be shocked. But you leave it the way it is. Because even if it goes to the hand of the external examiner, the student was entitled to get that mark. Because you can look for something to reduce it even by 1, but nothing. So we go for it. When you find such a jackpot, just go for it. And that's why I'm saying in essays, getting a 25 out of 40 is very easy. If we do well, if we plan well, how you want to score your marks, you'll get. So based on that, just give. If they say 4 examples each, give 4 examples. But what you've seen with this functional group, the last carbon will always be CH2OH. For the ketoses, the first and the second is the same for almost all of them. Now it just differs based on the number of carbon atoms. I'm saying 27, Roman 1, now talks much about given a K value of 1 times 8 times 10 to minus 16, prove that the pH of water is 7. And that's why I was saying we need the equation for water to dissociate to hydrogen ion and hydroxyl ion. You start from there. Then the dissociation constant is Kq, which we equated to Kw. But then this Kq, you have to equate it to hydrogen ions concentration, hydroxyl ions concentration over the concentration of water. Then is the concentration of water we are looking for. We are calculating the concentration of water. And that's why we are talking about 1 mole equating to 18 grams, because we are looking at the masses of oxygen and hydrogen. And that is what we are doing until we get 7. So you know the steps which we follow. Only at a certain point where somebody just guess and then you arrive and say 55.56. No, let it be clear. At that point where you're talking about 0.556 times 10 to minus 2, it is not minus 2, it is plus 2. You know, plus, you move 2 steps ahead. But minus, you are moving 2 steps backward. If you move 2 steps backward, you'll be adding 2 more zeros. But our initial value was 55.56. So let us be precise in that as we derive the normal pH of 7 for water. Show a reaction on how water acts as a buffer. That is what you are showing me. 2 water molecules forming the hydronium ion and hydroxyl ion. Simple. You'll get your 3 marks. Discuss 2 properties of water, that is crystal structure and biological solvent. That one you can read on your own so that you can write whenever you see any property of water. Question number 28 says, discuss classification of amino acids based on, I told you this is how it can come in the essays, based on the number of carboxyl and amino groups, and draw structures of any 10. Any 10. Who doesn't know how to draw glycine? Who doesn't know how to draw alanine? Imagine. That is why I do monoamino monocarboxy, because I want people to get marks. I didn't even start by saying nutritional classification. Somebody might be confused now which ones were essential, which ones were non-essential. But monoamino monocarboxy, or sometimes I say draw all aliphatics and any any two, no, not any two, all acidic, all amido-acidic. Because I'm trying to be fair. At least you can get a 10. You can't miss something. And even the one letter code of glycine is obvious. Even if you didn't read much, but you'll get it. So I'm saying in that question as monoamino monocarboxylic and 2-diamino dicarboxylic, including the 1 and 3 letter codes. Remember how the 3 letter codes are obvious, but not for all. Like isoleucine, students will always write iso. It's not iso, it's ILE. But most of them is obvious, the first 3 letters. Only the 1 letter code can be confusing for like 5 amino acids. But most of them, like all the 15, the other 15 is easier. So in this case, I need you to draw any 10 monoamino monocarboxylic. You can draw all the aliphatic. You can draw the serines. You can draw the methionines. You can draw the cysteines, the threonines, as long as they're 10. And then give me the 1 letter code and 3 letter code. And then whatever you can also draw here, I've said even the 2-diamino and dicarboxylic, you have to draw the asparagine and glutamine. The 1 letter code for glutamine is Q. I could see crazy names. I don't even know where they got them from. But Q is for glutamine. Asparagine is N. Those are the diamino dicarboxy. But then the monoamino monocarboxyl are many. As long as you see in your structure, you only have 1 amino and 1 carboxyl. Discuss the effect of the following factors on enzyme activity. This one I gave on the handout. Temperature, just break it into 0 degrees, 20 degrees, 37 degrees, above 60, describe the way I described. Whatever it's all about, what happens, the formation of the products. You know at 37 is the optimum temperature, will form the products to the highest. Then draw a graph by saying up there, what is required to Cynthia? No, I can't give you an essay of discuss the characteristics of water. No, I'll specify. Though we said the questions, let us ask them later, Cynthia. I'll be able to address it. Remind me when I'm done. Yes, then I'll be able to clarify. Yes. So let us finish with the revision and then we can ask the questions. That is fine. Yes, I'll be able to clarify. Kindly, just remind me. So we were saying that for the temperature, just separate at 0 degrees, at 20, at 37, at above 60. Then you draw a graph. A graph has to have a title, effect of temperature on enzyme activity. Draw that curve. It's a curve which is well spread, bell-shaped to be precise. Then we have the pH, and I said for pH, each one of them will have a specific pH. The ones which work well on acidic cannot work well on basic. The one which work well on neutral cannot work well on basic, neither can they work well on acidic. So each one of them had the best pH. Just describe the way it is described there. Substrate concentration, we said the active sites on the enzymes are available for the substrate to bind. But when it reaches the saturation point, there are no more sites on the active site for the substrate to bind. So you can discuss, and then each one of them, and then after the end of it, do a graph. But the graph should have a title, effect of substrate concentration on enzyme activity, effect of pH on enzyme activity. 29, discuss disaccharides, including structures of monosaccharide components and glycosidic bond types. You know, here, you are going to talk a lot about the disaccharides, a lot. What lactose is, the milk sugar, reducing because of the free whatever. Sucrose, common table salts, the common table sugar, sorry. It is found is the most soluble, the sweetest of all. I don't know, whichever. You are going to talk about all those stories. But as much as we talk about the stories, draw it well. Draw the sucrose well. If you start with sucrose, you have the alpha D glucose as the first one. You know how it is. So since it comes downwards because it was below, it is going to connect to have a 1, 2, alpha 1, 2. Somebody asked me, Madam, why is it 1, 2? Then I told them, you know, it couldn't be 1, 4. The reason why it couldn't be 1, 4, already maltose has the alpha 1, 4. So the biochemist, that is what I'm thinking. The biochemist looked at it in this way. The keto group is at carbon atom number 2. So they thought as much, we should give much on the bond, linking much to the second carbon atom where the keto group is. So you talk about alpha 1, 2 glycosidic bond in sucrose. Beta 1, 4, if you talk much about in lactose. Alpha 1, 4, if you talk much about in maltose. But the first carbon atom talks much or give it much of weight of the name of the glycosidic bond. So draw them well and put the component of monosaccharide. Specifically, tell me that it is alpha D glucose and beta D fructose for sucrose, forming alpha 1, 2. Maltose, alpha D glucose and beta D glucose, forming an alpha 1, 4. Lactose, beta D galactose and beta D glucose, forming a beta 1, 4. Then describe. You'll get all your marks. Draw the structure of aliphatic. Do you mean that the equation, page 3 had nothing? Huh? Kumbe I'm almost, huh? Draw the structure. Did I get it wrong? Draw the structure of all aliphatic. So here I was direct. Draw structures of all aliphatic and sulfur-containing amino acids, including their 3 and 1 letter code. In fact, this question I can remember. This question I had set for the first group of BMLS upgrading, the first cohort which I had, because it looks very simple. It just direct. It tells you to draw the alanine, the glycine, the valine, the isoleucine, the leucine, the proline, 3 and 1 letter code. The sulfur contain you have methionine and the cysteine. But it shall be well. It's easy. Question number 31. Use of competitive inhibitors as chemotherapeutic agents. That was also in the handout. We saw that the inhibitors will always hijack the normal reaction of the substrate binding to the enzyme active site, forming ES complex, which further form a product and leaving the enzyme free. So we talked about reversible inhibitors. That is where the competitive inhibitor was falling, non-competitive and uncompetitive. So if you look at the competitive inhibitors, I said most of them have been used as chemotherapeutic agents in treatment of gout, in treatment of bacterial infections, in treatment of atherosclerosis, in treatment of high blood pressure. So the best example, which I talk much about always, is the one for treatment of gout. You know, gout is as a result of the uric acid. And this uric acid is as a result of pyrimidine degradation. It's not purine, it's pyrimidine. So the pyrimidines, if you talk about the pyrimidines, they more likely fall under the nucleic acids. They form part of the structure of the nucleic acids. So those are the bases we're talking much about. So you find that the enzyme xanthine oxidase, if the hypoxanthine, which is the substrate, binds to the xanthine oxidase, it gives us uric acid. And that is what brings pain on the joints, the gout. But allopurinol, one of the drugs, is a competitive inhibitor of the hypoxanthine. They look similar in structure. That is why they compete for the active site of the enzyme. So instead of it bringing about uric acid, which brings problems to individuals, the drug will come in. It will lock the formation of uric acid. That is how The competitive inhibitors have been used as chemotherapeutic agents. So we also have drugs like methotrexate. I think methotrexate is the one for which can manage the leukemias. Not sure, but they're used as chemotherapeutic agents. So I need to get back and check. But that is how important the chemotherapeutic agents are, or the inhibitors are, as chemotherapeutic agents. So then the next one says, discuss enzyme inhibition types. So you'll be able to discuss the irreversible and the reversible inhibition types of enzymes, where we have the competitive inhibitors. You define how structurally they look similar with the substrate, so they compete for enzyme active site, and then you draw that reaction where we have the binding of inhibitor to the free enzyme but not to the enzyme substrate complex. Then you have the non-competitive, irregardless of whoever binds first, but then we have the formation of ESI, enzyme substrate inhibitor complex, and enzyme inhibitor complex, but it binds to free enzyme and the enzyme substrate complex. Then the last one is uncompetitive. It binds only to the enzyme substrate complex. And then the irreversible will always form a covalent bond. So those are the discussion for the enzyme inhibition types. Question number 33, I think we already worked on it. Structural examples, 3 structural examples discuss the criteria for naming of monosaccharides. So here you need to draw 3. The other one was 4. So we already discussed it up there. Question number 34, we've also discussed the disaccharides in details with reference to relevant structures. You'll have to draw the structures. You have to specify the monosaccharide component. You have to specify the type of glycosidic bond formed. Question number 35, classification of proteins based on solubility and shape. So in shape is where we could talk about the fibrous and globular proteins. You have to talk about them, introducing the shape, which are the globular proteins, the fibrous proteins, and you give examples, and then you discuss each one of them. Solubility, we have the histones, we have the globulins, we have the albumins, the ones which are soluble in water, soluble in alkalis, the ones which are partially soluble in water. So that's how you are going to discuss them. These were in the handout for my other students, but then for BMLS app, we did it in class. So we'll be able to discuss. This is just something to write, so you need not to draw any structure. 36, discuss by defining and give structures of any 2. Yes, look at how question was very simple. So this one is an essay which covers the fatty acids. 20 marks. Discuss by defining and give structures of any 2. You go to saturated fatty acid, you define no double bond. Monounsaturated, there is a double bond, but 1 double bond. Polyunsaturated, 2 or more double bond, including their common names. Caleb asked that one. You see here I'm giving you a very free mode. Free mode. You describe fatty acids the way you want. You are going to get marks. You see? Common names, position of the double bonds. So if you start with saturated, you've defined it. Well and good. Give me C16:0. You know, they don't have double bond, but that is what I'm going to mark. Draw it. Write the common name. Palmitate. You go again to monounsaturated. 16:1, delta 9. It has to be exact. Don't just throw things which you don't know. Then you say palmitoleic. Then draw. Imagine you get marks for that. Just by telling me delta, the correct one, 18:1, delta 9. Common name, oleic. Already you scored your marks. 18:2, delta 9, stroke 12. Linoleic. You get marks. 18:3, delta 9, 12, 15. You get mark. And tell me linolenic. Then draw the structures. You've already defined them up there. Imagine 20 marks. And in this case, for you to get the 20, It means the structures were going for a lot of marks, even 2. And then the position of the double bond, maybe they were going for 1, 1. Because for it to be 20, it is going to scoop a lot of marks. Using any 5 structural examples, in each case, discuss nutritional classification of amino acids, full names. Imagine, I'm giving marks now, even for full names. 1 and 3 letter codes. Yes, maltose, water is released. Ogutu, maltose, water is released. At any point, a glycosidic bond is forming, water is released. Imagine, we are finishing with this one because I don't see the other one. I think page 3 had nothing. I don't know why I had page 3. But I'm saying, still, Issei, any 5 structural example, nutritional classification. I want you to define for me essential amino acids, non-essential amino acids. Give any 5. Imagine. In essential, we have 11. You can choose the ones which you can know how to draw. In non-essential, we have 9. Choose any 5. Imagine, even the full name, you are getting marks. Full name. 1 and 3 letter codes. We can't miss getting a 10 now. If you get such a question, see, you can get a 10 or even 12. And then the criteria for naming of monosaccharides. See, you can get another 12. See, that is 24. We are fighting for only 11 in the other sections. You have 35. It means the can't, you shall have scored even a 15 out of 30. We are strategizing on how to get a pass. Questions now? We are done. As much as it's 7 past 11, but I thank you so much for your patience. And today, the way my face looks dim. And do you know, my BMLS students haven't seen me. Only Amadi has seen me face to face. So they're wondering, this madam, this kind of face, is that how she looks like? We skipped question 26. Very good. Let me go back. Which one is that, my dear? Let me see. Oh, yes. Good. And this is what I was looking for. Do you know how special this question is? Do you know how special? Who has said that one? Zioka, thank you so much. This question, I had set this question in the card. And this was the question which was terribly answered. And I want to tell you what we are supposed to answer. I say, discuss any 2 homopolysaccharide. Any 2 homopolysaccharide. Somebody is still writing for me glycine, and somebody was still writing maltose. Somebody even wrote mannose. And somebody was talking about glycogen, a component of glucose. Amylopectin is found in glycogen. It is good. Zioka, thank you so much. This is what you need to do. This question talks about starch, glycogen, cellulose, dextrin, which we didn't discuss in class. The other one is which one? There is one. So if you look at the homopolysaccharides, the hydrolysis will only give us 1 monosaccharide component. In this case, is only glucose. For the heterosaccharides, I gave you as an assignment because the hydrolysis is going to give us one of which has an amine or acetylated with some of the monosaccharide components. So that is the name. They're known as heteropolysaccharides. But for the homopolysaccharide, I said any 2. If you define starch, I was giving half mark for that starch just by mentioning starch because you've identified the starch. If you talk about starch, say the carbohydrate found in plants, and then you go straight and mention for me the amylose and amylopectin. Most students were writing it as amylase. It is not amylase. Amylase is an enzyme, amylose and amylopectin. At amylopectin, talk about the linear. It is linear, not branched. It has the alpha 1,4. Still, they have the alpha D glucose as the component. We talked about 200 to 2000 for the alpha D glucose units, which are found in starch. But then amylopectin is branched, more branched, 20 to 30 glucose units. It has alpha 1,6 and alpha 1,4 glycosidic bond. Those were half-halves, so that we can get the 10 half-halves. Glycogen is a form of carbohydrate in animals. But what I mentioned in class is its similarity with amylopectin is that they are both branched. But the difference is glycogen is more branched than amylopectin, because for glycogen you have 8 to 10 glucose units, then you meet a branching point. For amylopectin is 20 to 30. The other difference is amylopectin is in plants, but this one is in animals. So that question is very important. Then cellulose is also one of them. Cellulose is linear and it has beta D glucose. But we gave examples of cellulose. We talked about wood, but we also mentioned something. It cannot be digested by humans. Only the GIT bacteria is capable of digesting it. Those points were very important. Nzioka, thank you so much. I saw it, but then I asked myself, where did it go? Kumbe nilipita. And then the next one we've discussed, right, Nzioka? So that one we can leave. Using structures, discuss monosaccharide classification. Sure. Good. Yeah, so good too. You are very eager to see my face. And then this thing disappoints me. I don't know where the foggy has come from. But don't worry. You will see me on 10th. No, that is me. That is just me. Even the voice will tell you with me. Don't worry. We will see each other. Good. Now, can we see the questions, please? The people who had questions hanging, so that we can answer, because people are already tired. You know, we are just human beings. The brain can survive with glucose for a little time. Ogutu, thank you so much. Thank you. So I thank everyone for being patient with me. As I was mentioning, the face, the way it looks, it's okay. I don't know why today that just disappoints. You know, these other days is fine. And somebody was telling me, we can lend you. I don't know. That person was not even one of us. But just omit those comments. This, my phone is Samsung F05. I don't know whichever. It has much higher camera, which can focus. So whatever somebody thinks about you, don't mind. You know yourself, huh? But then I'm very grateful. Question 14 says something about globular. Is it globular proteins? Edgar, thank you so much. Epic zone, question number 14. Is it classification based on shape? Yes. Question 14 was saying differentiate between fibrous and globular proteins. Epic, are you in the BCHD, BPH, or BMLS upgrading? Because for BPH, EVH, BCHD, or oral health, I gave the handout. I didn't cover proteins in class because time was already running out. But if you look at the classification of proteins based on shape, they were classified as globular proteins based on that ovoid shape, globular proteins. And then the fibrous one, you'll find they have the cross-linked network, something like that. So you have to define them first, and then you give the examples. So from the name globular, the globulins are going to fall under that class. So just by mentioning the classification, that is classification of proteins based on shape. Caleb, thank you so much. You, my students, you people are great. Both groups, all groups, I appreciate. The journey has been long, from week 1 to now the final week where we are doing the second cuts. I appreciate the efforts each and every student has made. So at this point, I also say thank you. Even to coming online for revision, I have to say thank you. All my students for all the programs, be it MBChB, be it BFARM, be it BCHB, no one is left out. Because our aim is to make biochemistry simple. Thank you so much, everyone. We have to accommodate all in this journey. My friend, and I already saw it for the cat. My student who has done it several times, I know them and I won't mention. They've put an effort and it is working, it is working, it is working. It is magical. I thank you so much, everyone. And I'm very happy when I see the students who have tried it several times. Madam, I've tried. I tell them, no, don't leave it. Here is where the hope comes. We are going to pass. And it is when each and every one of us put an effort. How do you know the carbon atom to place double bond, amino group, or carboxyl group? Dominant gene. The dominant gene. How do you know the carbon atom to place? I don't understand this question. Do somebody understand it so that you can make it clear? Dominant gene. Are you asking how to draw an amino acid? What I tell you is, from your question, the way I can understand it, if you look at the structure, Beatrice, thank you so much. We are not going to leave anyone. As long as don't have Mwakenya in my exam, my friend, you will see the other side of me which you never see. Because we are struggling here so that we can make it work and we understand whatever we are doing. Let me answer Nani first. Mafusa has, is that correct? If you draw lysine, Mafusa, how is the C, the alpha carbon with the H? You know, the hydrogen, you know, people assume that glycine can be drawn like two of the H's. No, oral health, good. I'll get back to you. You have to clearly put the R side chain as H alone. So what are you drawing here? So the H should come down. You see where the alpha carbon is. And then, or you can put COOH down and then the H. The H has to separate with the H for the alpha carbon. So the R should have its standalone H to show that that is the R side chain. So don't mix it. There was a time a student asked me if they can draw it as CH2. No, it stands alone as its own H on the R side chain. We have the carboxyl. Whether you want to put the carboxyl up, amino up, the alpha carbon in between here, and then there is a H here. This other H should define the R side chain. I skipped somebody. Who was that who was asking? Dominant gene. Dominant gene. I had to ask. I had to answer you. What did you mean? I think you meant how to draw an amino acid, but place it well. Dominant gene, place it well. Carboxyl. Because all amino acids will have the same carboxyl terminal, amino terminal, alpha carbon, hydrogen up there. What differs is the R side chain. Good. Ogu to the candle is lit. The hope is soothing. We live to see it as, thank you so much. I could not type it down. Yes. So if it is down, Mafusa, if it is down, then it will clearly show that is the R side chain. Because for all the 20 amino acids, we have the carboxyl, we have the amino, we have the alpha carbon, we have the hydrogen up there. So glycine, that H itself, makes it the simplest amino acids to draw, and that H should not be interfered with. Yes, thank you. I can see dominant gene. Agreeing. Do we call it a night? Is somebody having a pinching? Do you know a pinching? The one which when you go to sleep, you'll think, oh no, why couldn't I have asked madam? Ask that one. Sissy, yes, thank you so much. Thank you so much. And we shall pass. You know, when I see the students getting the concept only, it makes me happy. And that's why when you see me walking when you are doing your exam or you're doing your cut. I'm checking in a good way. Just open your paper, I'll check. Sometimes when I knock your paper, I tell you, I don't talk. I knock somewhere where I've seen an error. Take it positive. And I make you to think so that you can change it. I just knock where there is a problem. If it's something minor which is going to cost you a mark, yes. So, should we say good night? And I still thank you all. We'll turn up for the cut. For my upgrading, we are doing it on 10th. We'll start with the cut. That is the communication which Peter did to you people. We'll start with the cut from 8:30, 1 hour to 9:30. Even if we finish by 10, because we'll have to revise as well. Then you can have 10 minutes, then you rush to the lab. The labs, you can even go until 1, because I could see there is another practical, phlebotomy, or it was something like that. I don't know, histology, something like that. But my time is until 2. So they can give my students time. The 3 hours is enough. You will do the practicals for biochem and you'll get the results. I know it's a bit intensive. That week will be very intensive. And that's why I thought of us revising this time or today, because that week you people are busy and we're just human beings. You can get tired. So that I give you time, you people go and absorb. If you go back again to the videos before we can do exams, all will be well. We can't put all this effort and then we still not get it right. It shall be well. But still, if that time you have something to ask me after the cut, even for my BPH, BCHD, if you have to ask something, you will ask before we can do the main exam. So with them, they're having a cut on Friday, and we'll start with BCHD at 10, only 10 marks, 20 minutes, 10 marks. It will add to the other 50 for Biochem 1. Caleb, entering heaven is very difficult, my friend. Only Angel Gabriel knows. But thank you so much. Please, you people, have a good night and keep safe and try to work hard. Yes, thank you so much and God bless.